In this tutorial, we'll explore the differences between SQL relational and NoSQL non-relational databases, focusing on practical code examples and real-world usage. This guide is designed to help you understand when to use each type of database system and how to work with them effectively. We'll cover Let's dive into these powerful database technologies.
What are SQL and NoSQL databases?
SQL databases, also called relational databases, organize data into structured tables with predefined schemas. Popular examples include MySQL, PostgreSQL, SQL Server, and Oracle. NoSQL databases store data in various formats like documents, key-value pairs, wide column stores, or graphs. Popular examples include MongoDB, Redis, Cassandra, and Neo4j.
How do data models differ between SQL and NoSQL?
Well, let's look at some code examples.
SQL data model.
In SQL, we define tables with strict schemas. This code creates two tables, users and orders. Notice how we use a foreign key to establish a relationship between the tables. Each user can have multiple orders, creating a one-to-many relationship.
NoSQL data model, MongoDB example.
In NoSQL databases like MongoDB, we work with documents rather than rows and tables. This code shows two approaches: embedding related data, orders inside the user document, or using references between collections. NoSQL allows for more flexible data modeling based on your access patterns.
How strict are schemas in each database type?
Let us look at some code examples.
SQL schema enforcement.
SQL rigidly enforces the schema we define. In this example, the second insertion fails because email is required, and the third fails because we're trying to insert a column that doesn't exist. Any deviation from the schema results in an error.
NoSQL schema flexibility.
NoSQL databases like MongoDB are schemaless by default. As shown in this code, you can insert documents with different structures into the same collection. One document may have an email field, another may have an age field, and another might have nested objects. This flexibility can be both powerful and dangerous. MongoDB does offer optional schema validation if you need more structure. This code creates a collection with validation rules, making MongoDB behave more like a SQL database for this collection. Documents that don't meet these criteria will be rejected.
How do queries differ between SQL and NoSQL?
Let's look at some examples.
SQL querying.
SQL provides a powerful declarative query language. You describe what data you want, not how to get it. The code shows a basic query, a join query combining data from two tables, and a complex aggregate query with grouping and counting. SQL excels at these types of structured queries and complex joins.
NoSQL querying, MongoDB.
Forgot and never brought to mind. Should all acquaintance be forgot and all lang syne? For all lang syne, my dear, for all lang syne, we'll take.
NoSQL databases typically have their own query languages, or APIs. MongoDB uses methods like find for simple queries and the aggregation pipeline for more complex operations. The code shows a basic query, a query with conditions, and a complex aggregation pipeline that performs operations similar to SQL's joins and aggregations. While NoSQL databases can perform complex queries, they often prioritize simple key-based lookups for maximum performance.
We'll take a cup of kindness yet.
How do transactions work in SQL versus NoSQL?
Let's look at some examples.
SQL transactions.
We'll take a cup of kindness yet for all lang syne.
SQL databases are known for ACID compliance, atomicity, consistency, isolation, durability. This code demonstrates a transaction that transfers money between accounts. Either both updates happen, or neither does. If an error occurs, we can roll back to the previous state.
NoSQL transactions, MongoDB.
Many NoSQL databases traditionally sacrificed full ACID compliance for scalability and performance. However, modern NoSQL systems like MongoDB now support multi-document transactions, as shown in this code. The transaction ensures that funds are correctly transferred between accounts, similar to the SQL example. Not all NoSQL databases support transactions, and there may be limitations compared to SQL databases. For example, distributed NoSQL databases might support transactions only within a single shard or node.
How do SQL and NoSQL databases scale?
Let's look at some examples.
SQL scaling, vertical and read replicas.
SQL databases traditionally scale vertically by adding more CPU, RAM, and faster disks. They can also use read replicas to distribute read operations. However, true horizontal scaling, sharding, is often complex and may require application-level changes.
NoSQL scaling, horizontal sharding.
NoSQL databases are designed for horizontal scaling. They distribute data across multiple servers, shards, based on a shard key. This code shows MongoDB's approach to sharding, where we define how to distribute data across multiple servers. The system automatically handles routing queries to the appropriate shard. This allows NoSQL databases to scale to massive datasets and high throughput by simply adding more commodity servers to the cluster.
What are common use cases for SQL versus NoSQL?
Here are some code examples.
SQL use cases.
SQL databases excel at transactional applications like banking, ERP systems, and anywhere with complex relationships between entities. They're also great for business intelligence and reporting that requires complex joins and aggregations. The code demonstrates a financial transaction with asset properties and a complex reporting query that joins multiple tables, classic strengths of SQL databases.
NoSQL use cases.
NoSQL databases shine for the following: content management systems. The flexible schema works well for content where each item might have different attributes. Real-time big data, when you need to ingest massive amounts of data quickly. OT applications, where you have a flood of time series data from many devices. Web applications, with rapidly evolving data requirements. Caching. Key-value NoSQL stores make excellent caching layers. The code demonstrates how a content structure with nested comments fits naturally into a document model, and how high-volume sensor data can be easily stored without predefined schemas.
How does performance compare between SQL and NoSQL?
Here are some code examples.
SQL performance.
SQL databases have mature optimization engines and can be very fast for complex queries, especially when properly indexed. However, they can face performance challenges with extremely high write throughput, very large datasets that don't fit on a single machine, queries that need to join many tables with large datasets. This code shows creating indexes to improve query performance and using the Explain Analyze feature to understand how the query is executed.
NoSQL performance.
NoSQL databases often excel at high throughput operations, thousands of operations per second, scaling horizontally across many machines, simple key-based lookups, specific access patterns they're optimized for, e.g., graph traversals for graph databases. However, they may be slower for complex queries involving multiple collections tables. The code shows creating indexes in MongoDB, similar to SQL, and using the explain function to analyze query performance.
Important points to remember.
Thanks for watching.